First of all, thank you everyone at Swiss company and everyone from Bombay Ophthalmic Association. We heard excellent results. I've had a journey. I've implanted all sorts of multifocals, including the array almost 19 years back. So I'm just going to tell you practical tips that I feel about implantation of the new EDOF lens that I've been using. So what are the surgical steps you need to change and why? Loading of the IOL and removal of the IOL from the holder. So I'll show video for each. Viewing the IOL under high magnification is just for knowledge. The right size CCC in a femto case. We have to fill the bag well with a viscoelastic. Injecting the IOL and observing the unfolding of the same. Dialing the trailing haptic and position why it's a little different. And finally, the removal of the viscoelastic. So I'm going to entirely talk on practical aspects of using this IOL. So as far as the loading of the IOL is concerned, it's very, very simple. You have to make sure that we fill up methyl cellulose till the tip so that there is no air. Don't forget, this has a spring on the plunger. And that's the reason why. Now, this is how the lens actually comes. It's hydrophilic, as you can see. The top layer is removed and then the lens is sitting inside and then the lens is removed and placed onto the injector. Once this is done, it's just like any other lens. The injector is made by Metzel. Very good Swiss company too. Use a lot of their IA cannulas, which are excellent. And once this is done, just close the cartridge and push the plunger and observe that the trailing haptic is not engaged in the plunger. So you can see here actually the plunger pushing the IOL in the front. But there is a trick here that you will face when it comes to injecting the IOL. Okay, what do you really face? Very important that put the methyl cellulose till the end of the injector. Hold the plunger or else you will get air bubbles. So you'll see some of my videos with air coming out first and then the IOL. To prevent that, it's important that we hold the plunger. And that's the reason why. And don't forget to fill up the bag, not with methyl cellulose, but with a better viscoelastic. So I use Helon GV. So this is what I do. Actually, I fill up the bag properly. You need that space. And the reason why you need the space than any other IOL is what I will explain in all the following videos, because that pushes your posterior capsule away. And the unfolding of the leading haptic sometimes comes in the way. So that was creating the space. Now, what is a proper insertion? So here you will see the lens going in. Now you can see the air coming out first. Don't worry about that because the plunger was released. Now you see the unfolding of the leading haptic. It's looking down towards the posterior capsule. But the space is good because I've filled up the bag, Helon GV, no financial interest. Once I've done this, now there are two ways. You have to dial the lens in, okay, or you just place the lens in. So you will see here what I'm doing is just making sure that the whole haptic goes into the bag. So once the whole lens is in the bag, the haptic is in the bag, you just have to remove the viscoelastic. So this was a perfect insertion. Now let's look at a case where I did femto. Now I normally do a 5 millimeter rhexis on a femto. Now this is small for this IOL. So if you're doing a femto, you need a rhexis of 5.25 or a 5.5. So you see the unfolding of the leading haptic. It's looking down towards the posterior capsule. Be careful at this stage. Don't worry. What you can do, one way out is pull the haptic towards you. Now I'm going to dial the lens in. Okay, it's looking down towards the posterior capsule. Now this is scary because this we don't see routinely in our cases. So I found a technique where we can avoid this, and a 5 millimeter rhexis is sometimes IOL and from behind the IOL. Don't forget, this lens behaves a bit like a plate haptic. So there is a chance that the viscoelastic gets compartmentalized in front of the IOL and behind the IOL. This is a bimanual removal of viscoelastic. And sometimes you will see that under high magnification, you can see that the central elevation that you see about the main reason why this lens is performing so well, you don't see any diffractive rings that you see in any other multifocal or a diffractive IOL. Now I'm putting irrigation below the lens and then removing any viscoelastic behind the IOL. Once that is done, all the viscoelastic is removed. Occasionally, you will see a shimmer coming out from the center of the IOL. Remove the viscoelastic from front of the IOL and from behind the IOL. Now coming to the adjustment. Now what is a way out? Again, look at the leading haptic. It's looking down towards the posterior capsule. I have a good enlarged bag. It's full of viscoelastic. Now there's one handling this section. One handling is now I take a T, okay, and pull the optic towards me. So I'm sitting at 12 o'clock and I'm in incision and main. And when I pull the optic towards me, that haptic, which was actually looking down towards the posterior capsule, is actually straightened out. So at this stage, I'm just straightening out the leading haptic and making sure it goes in. As I mentioned, the dialing surface, okay, in this IOL is huge compared to any other optic haptic junction which we are used to, say an Alcon IQ or a Technis one, whichever lens that we are used to, has a very optic haptic junction, and so the dialing is very, very easy. So now I've adjusted the leading haptic, and then I put in the viscoelastic again, inflate the bag, so make sure that everything is good. And now I'm going to dial the haptic into the bag. So there are two ways of doing it. Now, when it comes to dialing, you will see that the dialing area is huge. Okay, and that's the reason why. I'll show you one more video why. And now I'm dialing this whole optic haptic junction into the bag. So it's quite easy, but I would prefer and think that we need a little larger rexus than what you would need in any other IOL. A 5.25 would be ideal. And you can see that the whole lens goes into the bag. The haptic has gone into the bag. We make it horizontal and everything is perfectly fine. Now coming to the next case, again, look at this. Same thing, you can see air coming out because there is a spring in the plunger. If you relax that spring, the air gets sucked into your cartridge and that comes out first. And that's the reason why you will see one more video where I'm going to show a video where there is no air coming out at all. Here again, I'm adjusting. This is a little small pupil as shown by the previous speaker. It's a Callisto. I have a Vion, which is image guided surgery. And again, I'm dialing the whole trailing haptic into the bag and adjusting the lens according to the required axis, according to the measurement that we do. So let's look at what actually is happening here. So this is under high magnification. And this is what I wanted to bring to the notice of everybody, that this is a toric Lucidis IOL. And here the surface area for dialing is huge. Now this is under high magnification. Normally you'll see rings, here you will see nothing. So that's the beauty of the construction of this lens. You can see that there is absolutely nothing seen. And this is what I wanted to bring to your notice, that this is the large amount of area that we have to actually dial into the bag. And that's the reason why we need a little larger rexus than normal. So here, this is under high magnification, showing that. And now we're going to put this into the cartridge and then inject it into the eye. And once that goes, the injection system is just like what I showed you before. This is again under high magnification. You don't see any rings. You may see a little elevation in the center, and again filling up the bag and making sure that this is just the last part of dialing, because that was a large surface area of the optic haptic junction which has to be dialed in. So you can see that the whole haptic gets dialed into position. So this was one thing that I wanted to bring to your notice compared to any other normal IOL that we are used to using for so long. The trick here is, look, there is no air coming out. And now I'm going to show you a bimanual technique to prevent that haptic from looking towards the posterior capsule. So what I'm using is a Sinskey hook. You can use a T, you can use an iris repositor, you can use whatever you want. The right hand is injecting depending on your dominant hand, and then just going, making sure that the haptic is looking upwards. Once that is done, everything is fine. No air came. Mind you, friends, no air came because I had held on to the plunger. There was no negative suction. No air was sucked into the cartridge. And now coming to the last part, which is dialing, you go above the optic haptic junction, okay, go around it, and then dial the whole trailing haptic into the bag. Now this was again a 5.25 millimeter, and now we will show you this. I'm making the lens horizontal, as we all know that the lenses have to be placed horizontal. Let us look at high magnification. Now this is under high magnification, you can see a very well centered IOL. Occasionally you can see the rings, which you can see in the center. Otherwise it's very well centers. It centers quite well. I've used the lowest diopter. I've used the 7 to 8 diopters, and there was no issue of rotation. Otherwise, we would expect that this should be an issue as far as it comes. So this is just to check. The size of my rexus is 5.5 millimeter. The actual one I made is about 5 millimeter, and the actual optic is 6 millimeter. This is just a retrospective analysis of the same. Same thing here. Another trick, another case, same thing. No air coming out. Using the other non-dominant hand, making sure that your bag is fully filled with a viscoelastic, and making sure that the leading haptic, when it's pointing down towards the posterior capsule, is actually adjusted by the other hand. and made it look upward so that we make sure that it doesn't touch the posterior capsule. And this is one care I feel that we need to take when we are implanting this IOL. And that's because of the design. I tried many other methods of loading this lens, but this is just a thought. And once this was done, this was a toric IOL to be implanted at 56 degrees. Once this was done, we just go ahead and dial the lens into the place. Once that is done, we go ahead and remove viscoelastic. Again, mind you friends, the viscoelastic removal, either you do bimanual or coaxial. This whole lens behaves like a plate haptic. So the viscoelastic from front of the IOL and the viscoelastic from behind the IOL has to be removed to make sure that it sits well. And this is how it maintains its position. So the results are brilliant. I have a machine called a glarometer made by Takagi. I think we are the only ones in India who have it. And doing a study on this IOL as to what the results are. And I've also used the Synergy lens from Johnson & Johnson. But this is so in conclusion, I think it's a brilliant product. I feel that you have to hold on to the plunger so that no air actually comes out for the injector. CCC in a femto should be 5.25 or 5 millimeter. I find it a little less to be able to dial the lens in. We have to fill the bag with a good viscoelastic so that we get the posterior capsule a little away. I would like to use a bimanual technique to implant the IOL to prevent the leading haptic from touching the posterior capsule. Dialing the IOL, don't forget that it's a long surface area of contact between the optic and the haptic, and that's the reason why the dialing is a little longer than normal. Dialing the IOL, once you dial the IOL into position, viscoelastic removal has to be in front of the IOL and behind the IOL. In high myopes with larger bags, I don't know whether this overall diameter of the IOL is good enough. So I think they have another IOL which is larger in overall diameter. And in my hands, I've seen no issues about rotation. I find it extremely stable. I have a machine called glarometer. It actually measures glare, contrast, sensitivity, and halos in different light conditions and pupil conditions. It's made by Takagi, and we are doing a multi-led study on this. And very soon we'll have a data with the Lucidis IOL too. Thank you all for your attention. Thank you once again, everyone, to have given me this opportunity.